Hi, everyone. There is two updates, one regarding the next week's session as well. So we will start next week at 11. It will be one time only. Instead of 10, we will start at 11. I will post it as well on the Slack. And also, we have changed the meetup time. So I assume you should receive update that the time has been changed. It's just one time and just for next Saturday. We will start at 11. This is one thing. Another thing, because we were targeting today to cover stack and heap, I'm doubt that we will have time to cover heap, and next session most likely will be covering heap. Heap is less. I think probably we will touch a little bit tree next time, but maybe it will be just also just heap next time. But today, I think we will purely focus on stack problems. So yeah, I think that's it from the organization questions and stuff. I believe, yes, I covered everything what I want. So everyone is having links for whiteboard, right? I start sharing my screen now. Here, so this one. So, okay, introduction to the what we are going to cover today. We will cover stack. First we will walk through the primitives. What is the stack? What is the main methods? The time complexity. Then I will move what kind of patterns at task falling down under stack. We will dedicate quite a time on understanding what is a monotonic stack. And the last one will be covering quite complex for myself, at least problem, which is basic calculator or some expression how we calculate with the stack. It's a very popular one and it is very brainy, but people still asking it during the interview. So this the agenda for today. Okay. Everyone is having okay, and there is our next week challenges, which we will cover during the class, and then you will solve it on the week. Okay, let's get started. So introduction to stack. Stack, it is a data structure which is follow the principle last in, first out, meaning the most recently added items is the first to be removed. It's usually used push and pop. So for example, we will push, as you can see at this picture. So we will push 1, then we will push 4. It will be on the top. How we will pop out the elements? We push the last element 4. It will be first who will pop out of the stack. Means pop, it's we're removing from the data structure element, and I need to update this. And here it will be again pop. Just 1 second. It will be pop 1, and yeah, yes, will be a stack which is empty. So this is the main operation which we will use on the stack, and they all perform in terms of time complexity in constant time. That's why you will see why we will use in some certain task. So yeah, I covered this one. What does mean push and pop? What does it mean last in and first out? So this is the principle, and where it's applicable to use stack. Handling nested structure. So just we will cover most of them today. So it's useful for parsing or validating nested structure, such as parentness, or when we will try to solve basic calculator. There is also will be nested operation, which is for which we will use stack. Reverse order. It's used as a recursive call, all the stack, instead of recursive call, because under recursive call, it is also used stack. So who is confusing about this? It is not very important at this moment, so you can skip it. And monotonic stack. A lot of LeetCode questions falling down to this structure, monotonic stack. We will cover in deep just in like 15 minutes probably. Okay, any questions on the what I just told? Okay, moving. Let's try to solve our first task, which is valid parentness expression. This is the easiest one out of the parentness task. There is some a little bit complex one, but this one I would say from the what I saw so far around the parentness, it's the easiest one. But it is very sophisticated in my opinion. How we can solve it? So let's go to the description. Valid parentness expression. Given a string representing an expression of parentness containing only this parentness, determine if the expression form is a valid sequence. A sequence is valid if every opening parentness has corresponding closing parentness. No closing parentness appear before its matching opening parentness. Means, so for example, we have this string as an input. And we have the proper order. If we open this parent, it will be closed in the right order. Then we open this one, and it will be also closed in the right order. If we compare with this input, here we see that one parent without closing one. That's why it's false. It's not a valid parenthesis expression. From the description point, everything is clear. What is asked? Okay, cool. Moving on. So let's take as an example this string. If we will simply count open and close string, we will actually confirm that it is valid. But it is not valid because the order of the parentness is not right. So it should be false. Meaning we need to find a way how we are going to count the order of parentness. So means once we open, we should expect that in somewhere down the string, there will be the right close parentness first, and it will be in the right order. So I hope it's clear still why we just can't count open and close parentness. Okay. So this is basically the same things which as I just told. So I skip it. You will read it. Now we have key observation here. Is the most recent opening parentness we encounter should be the first parentness that get closed. So opening parentness are processed from most recent to least recent, which is indicate of last in, first out dynamic. What does it mean? So for example, we have bunch of parentness, but most recent, so basically we just open, and now we expecting that most recent in this string will be closed, right? Then it will be valid. We are not expecting here this one or this one. We're expecting just the most recent opening parentness. Then we will expect this one, and we'll expect this one, which should point us what if we will use here stack, because this is exactly the dynamic which is stack is using. Okay, this is clear. Cool. So stack. Here's the high-level strategy for the using. So add each opening parenthesis we encounter to the stack. This way, the most recent parentness is always at the top stack. We encounter a closing parentness, check if it can close the most recent opening parentness. If it can close, then pair of parentness by popping of the top stack, if not, in the string invalid. So I will cover one second, just we'll walk through the code. I think it should be updated. Yeah, okay, we have stack, parenthesis contains C, stack push. If stack pick, one second, parenthesis contains C, stack push. Stack, then we encounter one, match stop, poop, stack, push, stack, and it does not, just one second. Okay, yeah, now let's walk through the example that you understand this high-level stacks. So first, we encounter first one. This is the opening one. We are putting this on the stack. Then we push another one. It's still open one. We are pushing it to the stack. Now we encounter the close one stack, the close parentness, and it match top. Then, so it is matched. We encounter the most recent opening parentness here. Whereas once we encounter it, there is no we no longer need to keep it on the stack. So we pop it, and now here on the stack we have. Don't be confused. It's not parentness. It is just stack here. This is our stack. I will put like this, or I want so that the stack is currently holding just one opening. Next, we will encounter another one open. We again will pop to the stack. We will push this open parent to the stack. Next, we will encounter closing braces, and we check if the on top of our stack is actually the one which is we expecting, but it is not. So we can right away return that it is this string is actually invalid. So basically, what we are going to do in stack, we will keeping only open parentness. And once we will encounter the closing one, we will compare if the on top is actually the one which is expecting the closing one. For this reason, I will come back to this edge case. We will maintain also a hash map in this task. So one second. So C, parentness contain key. We will push this. Then we encounter pointer. We can take stack pick. We will compare with the C and stack pop, return false. Okay. So first we, if we will walk through the code over here, initially we will introduce a hash map. We will introduce empty stack. We walk through our input string. Here we will check if the our map is contain any of this key, which is key will be pointed to the open braces. We will check if it's open braces, then we will push to the stack. Once if it's not open braces, then it means that it is closed braces. What we need to do? We need to do to get by key value of the closed braces here. That's what we are doing from the map. We are taking stack pick. Pick it's will return you the topmost braces on the stack. So means in this case we will take this for example, it will return our value, which is closing braces. We will compare with the char, which has just come to us in this string. And if it's right, then we will pop the latest, which is this one, from our stack. If it's not, then we will return false. Also, it could be, in this case, I will just finish and we'll take questions. So it could be possible that in this case, we have this example. So means we will walk through all the string. We will popping up those one. It will be closed. But at the end, we will have still stack, which is contain two braces, which is doesn't found the pair of the close. It's also invalid. That's why at the end, we need to check if the stack is already empty. If it's empty, then we found everything what we need, and we can confirm that string is actually valid. Now questions. Moina is missing today, folks. I encourage you, if you don't understand, just ask questions. Okay, so it's clear. Amazing. Okay, cool. So yeah, how we handle, so basically we have map with their open and close parentness. We're using stack to Pika is built. Yes, I think let's see what is in Python as well, because I'm having in Python as well. It's pop. Okay, so this is how it looks in Python. So yeah. Yeah, please unmute yourself and ask.
Yes, actually, I understand here the time complexity of this algorithm, but I couldn't understand the memory complexity of this.
Memory complexity will be O10 as well here, because we are using stack to preserve all the parentness. It could be that we will keep pushing. So, for example, in the worst case, so for example, we will receive this string, and it's just this string, and we will keep adding this parentness on the stack, which is mean it will, in the worst case, will take O10 memory complexity. Does it make sense? Okay.
Yes,
cool.
yes, thank you.
Okay, moving on to the monotonic stack, then we will come back to evaluation expression. Its evaluation expression will fall down under one, which is I just explained. It is about to handle nested expression in the right. So it will be very similar to the parentness, how we will handle parentness. But because I believe it's very complex one, I want to start first from monotonic stack, and then we will come back to the evaluation expression task. Okay. Now I will share this scene as well. So monotonic stack. A monotonic stack is a stack data structure that maintains its elements in either increasing or decreasing order. Monotonic increasing stack, each element is greater than or equal to the one before it. Monotonic decreasing stack, each element is less than or equal to the one before it. So I put not in the right place. Let's put me here, somewhere here, this picture. So this is decreasing order, this is the increasing one. We use this data structure to solve problem when we need to find next previous greater or a smaller element in the array. This is clear, right, folks? To understand what is the monotonic stack is decreasing order and what is the increasing order. Okay. So why it's useful? Because for any, I will spot description of the task, which is usually falling down under this. So for example, we have problem for each element in the array, find the next element is to the right, which is greater. Or, so for example, here, 1 second, somewhere here, next smaller elements, that's great. In this one, or you given an array for each element, find the next element to its right, which is smaller one. If there is no such element, so for this kind of task, we usually using monotonic increasing or decreasing array. Depends on the condition which is asked, not only condition, depends on what it has been asked during the task. We will sort this out. So why it's useful? Because for many problems like this, when you need to find for your array next greater element on the right, you will use quadratic time approach. This is one will be the brute force. But if we're using a monotonic stack optimize, it will be optimize this kind of task to OR10, because each element is pushed and pop at most once. And push and pop time complexity, as I mentioned from the beginning, will take a constant time. It will make clear, just let's go down. So key principles. As you iterate through the array, you use a stack to keep track of candidate next greater elements. When you encounter, this is the key principles for this task. So we need to keep track of the candidates. When you encounter a new value that breaks the monotony, you need to resolve this. Pop and process the previous element. Now let's deep dive. What does it mean candidate mean here? When we talk about the candidate, we mean elements that might not have found the answer yet, the next greater or smaller element. As you process the array, you don't know for each element what is next greater and smaller element, as you need to wait to remember ones you haven't resolved. Let's take an example. So basically, this is the example. Let's see in the action. Yeah. Suppose, so we have this example here. Just 1 second. So for this array, we will try to find the next smaller example. In this case, our output array should look like this. If we're looking at next smaller element, so it will be 2 here. For 2, we will find 1, and for 6, it will be 1, and here it will be 1. Right? Yes, it should looks like this. Okay. Please chime in if I make some mistake or it is not clear. So we
Excuse me, I couldn't understand why our output this way. This is
how we receive this output.
yes.
Yeah. So basically, yeah, how so we so for example, for this input array of nums, we need to find next smaller elements for each of them. So means we will take 5 and we will try to find next smaller elements for 5. For 5, it will be next one smaller. It will be 2. So we need to build a new array, which will build from the next smaller elements of each elements on the nums. Means for 5 here we will put 2. For 2 we will put here 1 because this is our smallest one for 2, and for 6 on the right. This is the main moment on the right, not on the whole element. And here will be our 1. And for 1, as it's the last elements, there is no elements on the right. We will leave it as -1 because we haven't found any candidate for them. So now that we are saying about the principles, first principles is to keep tracking candidates. Now, in order to explain better what is the candidates means in this context, it means, so for example, 5, it's our candidate. We don't know yet what is his next smaller element. Means in this case, we will use monotonic, I believe increasing stack, where we will preserving our candidates. So in this case, we will take 5, value 5, stack is empty, we're pushing 5. It's our new candidate. We don't have an answer for this yet. We will save it on the stack. Next element will be 1. We will compare with what we have on the stack because we have candidate which doesn't have any answer yet, but we need to find this. We will take next element in our array from here. We will compare 2 and 5. So can it be our next smallest element? Yes, it can, because 2 is less than 5. So 2 is our next smaller element for 5. We found answer for this candidate. We clear our stock. We're removing this 5 from the stack. But we don't have answer for 2. We will push 2 on the stack. And we will update our output with our answer. So 2 now is our candidate, which is we are saving in our stack. Yes, just ask.
So in the first candidate was 5 and the next element candidate that we encountered is 2. So suppose we are encountering some number which is bigger than 5. So we are not popping out 5 at that time. 5 will just stay there if we are encountering anything greater than 5, like 6 or 7. So in that case, what will be the output?
In this case, as long as I understood, if there will be 5, then 6 and 7, right?
Yes.
We will build our increasing monotonic stack. It will be here will be 5, here will be 6, here will be 7. What it gives us understanding that so far, so for example, why we need this monotonic increasing array to use here. Here will be, in your ask, it will be 6 and 5. We didn't find answer for all these candidates, but we know that we're using increasing monotonic array. Once we will found, so for example, you will found element, which is, let's say, it will be our 5 here. Now that we know all these elements are in increasing order. So if 5 is work for 7 here, so means 5, it will be answer for 7. We will pop out 7 after all. Then we will do next. We will check 6 because we know this is increasing stack. So we can check our 6. It is our 5. So it is also, we found the answer for the 6. But 5 and 5 will not work here. 5 and 5. What it gives us to using a monotonic stack in this for this task, because all this operation like pick, pop, push, it take constant time. Instead of doing quadratic time, when we're taking all the elements from the array and we just going all the array and we compare and we are trying to find, we maintain our stack, monotonic stack. Depends on the what is asked, the order. That's why order is very important here to maintain, either increasing or decreasing. It gives us to answer the question. If we saw so far candidate, which doesn't have answer, but now we have num, which is possibly will satisfy all the candidates which is we maintain on stack, and this will give us opportunity to answer on this question on constant time and reduce the time complexity for this kind of task to O10, if it makes sense. If it's not, I will cover it also a little bit deeper. Does it make sense what I just told?
Yes, thank you so much.
Okay. So yeah. So to understand, just want to for you folks to understand what is mean candidate here. Why we're using stack to track all the candidate? It means candidates which doesn't have any answer yet. And depends on whether we're looking next smaller element or next largest element. So we need to use either increasing or decreasing order. For next smaller element, as I explained it, we will use increasing stack. So one, so basically this the summary. Just ask Vivian.
Hi, I was also wondering, is it also, rather than use a stack, can you just maintain a variable where you just keep track of the smallest amount so far as you're going through the list? Is that also an efficient solution?
You can't maintain variables. So for example, in this example, we have 3 candidates in our array, which is we don't have answer yet, right?
Yeah.
So you can't assign, in this case, variables. But in some tasks, yes, it could be replaced by the variables. It will be optimized to the variables. But in this context, so no, you can't use just variables. So you need to maintain stack here because you don't have an answer for 3 elements in our examples.
I see. And also because the output needs depends on, I guess, the position.
Yes.
And that's why we can't use a very careful perfect. Thank you.
Yes. That's the true. So about the candidate, just a summary. Each time you push an index on the stack, it becomes candidate for which you are waiting to find the answer. When a new value appears that resolves a candidate, you process and remove this candidate from the stack. The stack holds only unresolved candidates, and each is processed at most once. This is the most important. So what I'm trying to point it out and focusing on, why we're using stack here, because we're introducing space complexity. But on the other hand, it helps us to optimize this task to the linear time, because stack operate on the constant time. Regarding the candidates, is it clear? Don't be shy. If it's not, I will cover again. There is a crying smile. Saida, why?
Yes, I can't understand it.
It's fine. So you can't understand what does mean candidates in this task?
I understand it why we do that, but I don't understand it why we use decreasing and increasing.
I will cover it a little bit.
Okay.
I think I will cover it somewhere or key principles. Yeah, I will. You will, I will cover the opposite task where we're using decreasing and increasing. We will, yeah, let's move in 5 minutes and we'll cover it better.
Nice, thank you.
Nope. So what does it mean? Break the monotony in these key principles when we resolve. So this is, yeah, yes, Sandeep. Okay. So basically, what does it mean? A monotonic stack, increasing or decreasing, is a build to keep its element in certain order, as we discussed. And order is very important because this is how we know predictable dynamic of our candidates. That in increasing, it will be go from the top to the bottom in increasing order, and in decreasing, it will be the opposite. So that's why it's very important that we are keeping the order of them. And once breaking the monotonicity happen when a new value doesn't fit this rule. In this case, for example, 5 is came and it's breaking rule of monotonicity of the stack. And we need to resolve it. Usually how we need to resolve it, so we see that we have answer. So we're popping up all these candidates for which we found answer for 5. Done. Now we have our stack, which is contained only 5, and we push back another 5, which is another candidate. And we preserve monotonicity here. So we preserve order, the right order here. We didn't break our stack. This is basically, that's it about these key principles. Yes, Sandeep. Okay, maybe it's by mistake. So this is basically, that's all about key principles. What is the candidate and breaks the monotonity. Now, yes, just 1 second. I'm trying to understand what is next in my lecture. Let's use an example, increasing. So you want next small. What happens when monotonity is breaked? Okay, this is the more explanation. Yeah, now I'm ready to take questions, folks.
Okay, thank you. My question is, so in one time we are using either increasing or decreasing, right? Only
Yes.
one stack at the point of time. Okay.
Sometimes there is a complex task, which is circle array, but don't brain yourself. It's very rare questions, which is good. I never saw them during the interview, but usually, yes, it is either decreasing or increasing order. We will cover now free task. You will, I hope you will understand when we need to use increasing and when we need to use decreasing stack.
Okay. Okay.
Any other questions before I will move?
Just one thing, if you feel comfortable, can we just do the dry run quickly about the last task? I mean, I have some questions, but if I ask one by one, it will take a lot of time for all also. So just a dry run, yeah.
Dry run.
This one, like, yeah.
This one, okay.
Yeah.
So you will take index. This is next smaller example candidate which we're using. Yeah, I got it. Let me just walk through because I put 3 examples. Just want to understand if it will be. Let's use an example. Next smaller increasing stack. What happens when so rewarded step by step? Next create elements will be here. And the next smaller elements will be here step by step. Okay. Yeah, let's make dry run just to understand. Yeah, and we are good with timing. So we have input array, which is 5, 2, 6, 1. In this case, it will be asked to find the next smaller element on the right. This is our output. So for 5, it will be 2. For 2, it will be 1. And for 6, it will be 1. And here will be -1 because we didn't find any elements. In all these tasks, if you will look at the examples here, next great elements or next small elements, first step is to create output array, which is we will initialize with -1. It's the very first step. So in this example, this -1 will remain stay here because we will initialize it from the beginning and we won't found any candidates. Now we will take index 0. It's our value 5. Stack is empty in this place, so we push index. In stack, we will preserve indexes. We are not pushing values. This is also a very important moment. Usually, there is some task where we preserve value. I will come back to this one, explain when we can preserve value. But usually, we're pushing index of the element. In this case, we will push 0. So no answer yet for 5. It's our new candidate, which is we will have in our stack. So I will put it like this. This our stack, which will be up. And here, actually, index. It's not or like this. It's our index we preserved. Next, we found elements here, which is our index 1. Now we are comparing values with nums in I. So basically, it will be here. Here, we're taking our nums I, which is next element in the array. We're asking stack on the top. This is Python. So in Java, it will be just stack.pick, means we will take the recent one on the top candidate. At this moment, in our top candidate is 5 with index 0. So why? This is also understandable, right? So we're taking, let me put it here. So we took nums, which just will be like this, stack pick. So means it will be this one. Will be nums, which just will take element 0. This is clear, right, folks? Okay, cool. So that's why we're preserving 0 for our candidates in order to find the value. Because next we need to update this value here in our output as well. So now we found this candidate. What we're doing? We're removing our 5 from the stack because we found the answer. We're putting in our rest because we know index of these elements. For this rest, we know this index because we are preserving indexes, not value here. We're putting here under index the value of our candidate, which we have found. And after this, all manipulation, we are pushing 2 because we don't have answer here. So in code, it will be looks like this. So we are taking, there is a slide, our array. We compare it with current elements in the array. We are comparing it if it's good. So we're popping up index. We are updating in the index array result. This is the daily temperature. Sorry, folks. So we're updating. But it is similar. We're updating nums is here, and at the end, we are adding index of this element. Is it clear? Okay. So now on the stack, we basically have this one, which will be our 1 index, and here will be 2. This is our candidate, which doesn't have still answers. So we're taking 2, next element will be 6. 6 is bigger than 2, so no answer for 2 yet, right here. So we are pushing another candidate, which we don't have answer yet. So we will update. It's this way. It will be our index here 2 and the value 6. So now we encounter another one element, which is 1. First element will be this, our 6. Also, you see, this is increasing order. From 2 to 6 we are going. So for 6 we found a new found answer. Okay, we will update our res. First it will be here. How our output will looks like result here. It will be looks like this after these manipulations. So because first we found this answer for 6, we updated here. Next, next we know that is we're maintaining increasing order. So probably there will be an answer for the next candidate. And it is true. So 1 is less than 2. We are updating our res with this value. But now we don't have answer for 1, right? And we're putting and we're updating our stack, which will be looks like this now. Will be our 3, and here will be 1. This is our new stack. But as we finish all the iteration, we don't have any other elements here. So this will be -1 remains the same. And this will be our final output. Is it clear?
Yeah, just one quick question. I understand how you update 2 for 5 and 1 for like one is a smaller element for the 6 value 6. But when we so after actually processing 6 from the stack, the next element, I mean the previous one in the stack is 2.
Yes.
So when we get 2 and when we compare it with the 1, like it's concluded that 1 is smaller, but then how we get the index 1 to update it?
Because first we're preserving indexes here. Let's see.
Oh yeah. Right. Sorry. Yes, you're right. I was just comparing the values. I got it. Yeah.
And we're doing while loop. So basically, we're trying to find all the answer which is well satisfied. So, and here we're taking index and we're just updating it.
Yeah, got it. Yeah, thank you.
No. So this is next smaller element. As we are now, let's take probably step by step for next great elements. And you will understand where we need to use monotonic monotonic stack in decreasing with decreasing approach. So this is the opposite one, right? Task. We have nums input array. So if it's clear, I'm moving to this one in order that you understand the difference between when we need to use decreasing or increasing order. Okay. Cool. So we have yeah.
Sorry, Lilia.
Yeah.
Actually, I'm facing issue with my mic. I just got dropped quite a few times. I just wanted to understand, like, so we have an input array, and then we are creating this increasing and decreasing monotonic stack, right?
Yes.
If you can just walk through once for this next small element, the example, how exactly it is.
Yes.
Sorry.
It's okay. We just did it like 2 minutes ago. Let me see. 1 second. Let me see if it will be. Shall I do it for monotonic decreasing stack? And
Yeah.
Okay, just to make some difference.
Okay.
For the folks on the call. If it won't be clear, I will come back because we are good with timing. So let's just walk through the description. Now it will be changed. So next grade elements. Now we're looking for next grade elements. We have nums element. In this case, we are looking not the small one, but grade on the right. So means for 2, it will be 4. For 1, it will be our 2. And for next 2, it will be 4. And for 4 and 3, we won't found any next greater elements. So they will remain on the same, -1. -1, as I explained it, where it's come, you don't need to, you initialize initially your array with -1 answer. So now that we are going over the array, first index will, and also, so we initialize initially in any of this kind of task, we will initialize, we will create our output array, where we will put any default values which is required. Most of the time in next grade elements and next small elements, it's required to keep -1. Then we will cover the third one. It will be required to put on the default value 0. So depends on what will be in the description asked. We initialize our output array with -1. We will create our stack. At the beginning, it's empty. Now we will start walkthrough from the input array, and we will try to find candidates. If we won't find the right away answer from them, we will put them on the stack. As I explained it, this is one of the key principles where we are maintaining all our candidates until we found answer. So this is the main purpose of having a stack in this task. So first 1, 2. Apparently, we don't have an answer for them yet because it's the very first element. We will skip this condition and we will come to this. We will put on the stack I index, means index, not value. Means in this case, it will be 0, which is actually value 2. Our output will remains with -1. Next we will find 1. As we're looking for increasing, today we in this task we're looking for next grade element. 1 is not our answer for this because 2 is bigger. So we're putting next index for next candidate. It will be 0 and 1. And value, it will be 2 and 1. Our output will remains unchanged because we haven't yet found the answer. So we're not falling down to this condition. Next, we encounter another one. Next, we proceed to next elements in our initial array. And we take from the stack, on the top of the stack currently, we have 1. So we're doing pick. Actually, here we compare if 2 is bigger than 1, could be it's our next greater elements for 1. And the answer is yes. Once we will found this answer, in order we will remove 1 because we found answer and we're processing it. So as we are keeping indexes, not value, we know exactly which element in our output array we should update. And this place, is it clear, Fox? Sandeep, is it clear?
Yes, Celia.
Cool. Okay. Next, we will go with I3. So remember, we remove this one element from top. And now on the top, we have just 2. Now this is 0, 1, 2, 3. Okay, so I skip some steps. No, I not skip. Once we process this element, we found next grade elements for 1 on the top, but we didn't found answer from for these 2, right? So we put on the stack these 2. Now our stack here will contain 2 elements. It will be like this. Our stacks looks like on this iteration. Now we found another one element in our array, which is 4. We're taking first 2. We compare, yes, it's our next great element. So we are updating our result here. Res will be looks like this. In this case, first it will be our -1 because it's not yet first 2. Then it will be 2. Here will be 4, and here will be -1 and -1. This we just process the first 2. We will remove first 2, but because we are looping here, because we're thinking there is probably it could be applied the answer for the next element as well. So we are checking, and yes, we found another answer for another 2. We will update it here. It will be our 4. Now stack is empty. We go out of this loop because stack is empty, but we have our 4, which is we don't have yet answer yet. So we're pushing 4 to the stack. Next element will be 3. For 3, we also don't have answer because there is no element. We just will push our 3. This is not correct order here. This is indexes, so this is correct. This is, don't be mistaken, it actually looks like this with, from the perspective of value. So we will push. For those 2 candidates on our initial array, we didn't find any answer. That's why they will remain -1 in this in our final output. And our stack, we will finish stack with 2 elements on the stack, but it is not the issue. So we just need to return the result. I hope it's clear. So depends what you ask in the yeah.
Lilia, I didn't understand how this second update happens for 2. Like when I equal to 3, 4 greater than 2.
Say again, for this 2 or for this 2?
Yeah, for the first 2.
For the first 2, okay.
Like on the stack, there will be 2.
Yes, on the stack
And
there will be 2.
yes, so when we'll encounter value 4, so the top will be the second 2.
Yes.
So that will get replaced.
Yes.
But then there will be a first 2 also.
Yes.
How it is getting, like how the loop is?
Loop will be here, see? In the first iteration, as you have your stack here, which is will be 2 and 2.
Right.
So it will be first iteration. Here you will so basically, you will take, because I'm not from Python, but folks, if someone is not from Python background, this one is equal to what we have in Java. So we're taking stack pick here. In stack pick, stack pick, we're preserving index, right? So we're not preserving values here. Means stack actually will looks like this.
Okay.
This is not correct. This is will be 0, which is value 2, right? And here will be our 2 index with the value 2. Right. So on the stack, actually, we are preserving indexes. It will be 0 and 2. And when we're taking first index, it will be 2. Value will be 2. And this value is 4. So 4 is apparently greater than 2. Okay, we will popping up stack. It will be it will return as index. In our output, we found the index, which is will pointed to this value, and we will update it with nums I, which is 4 here. Next, as we did pop. So there is no longer this first 2. There is will be remaining the first one too. Next, as we in the loop and we're not breaking the condition of this loop, stack is not empty here, and we still satisfy 4 is still bigger than 2. So we're popping up next our 2, which is index 0, and we will update it to the 4. Does it make sense?
We are not incrementing I here, like num of I is still pointing to 4.
Yes, num I is not updating. See, we have this for loop. Inside of for loop, this is just we're walking through the all the all these all
Array
the
element.
yes. But inside, see, there is while loop
Mhm.
actually. But because of operation on the stack is taking constant time, this is nested while loop is not contributing in quadratic time, because all the operation which is we're doing with stack is actually constant time. This is the beauty of having a stack and this task. Instead of looping through the array twice time in quadratic nested time, we're introducing while loop, but in this sense, we are just popping up all the elements, which is constant time. That's why it's not contribute into time complexity.
Okay.
Yeah. And once we process this one, nums, we added them as a candidate here in stack. And on the next iteration, we will try already found answer for this candidate.
Okay.
So now depends on what you ask in the task. If it's smaller elements you need to find, or it's next greater elements, you will choose which monotonic array you need to process, whether it's decreasing or increasing order. If we will come back to our next greater elements, we will put 5, we will put 4, and we will put 3 here. Why? Because in this case, for 5, 4 can't be is the answer, right? So that's why we're using decreasing order monotonic. Because if there will be 7, it will be most likely will be answer for our 5. That's why we are not putting in next greater elements any greater elements which is already for the elements on the stack. And the opposite things for increasing order. When we are looking for the smaller elements, it's apparently all these elements which is on top of 1 can't be an answer for our 1. That's why it is increasing order. And for next greater element, all these candidates above, which is we haven't yet found answer, can't be our answer for 5. That's why we are keeping these candidates in decreasing order for next largest element. And for increasing order, we are using increasing monitoring stack. Is it clear? Okay, folks. Now that I explained it, I took very primitive one task, which is next greater and next smaller element. Usually this task doesn't sound like this during the interview or on the LeetCode. This is the one example. Actually, I want to close this. Let's try. This is the task from your homework. So how it is usually sounds. Daily temperature. Given an integer array temperature representing daily temperature, write a function to calculate the number of days one has to wait for a warmer temperature after each given day. The function should return an array answer where answer I represent the wait time for the warmer day after the if days. If no warmer days is expected in the future, set answer to 0. Let me walk through the input. We have as an input our temperature, which is on each date. So for example, today it was 65. Next day it was 70, 68, 60. We need to return the output. So for example, for this date, when will be next warmer temperature? for this day, it will be in 1 day. We're putting it's 1 because 6.5 today, and next warmer temperature will be 70. So we're putting it's 1 here. For 70, it will be in 4 days. 75 is the first warmer temperature for 70, and it will be in 4 days. For 68, it will be in 3 days. For 60, it will be in 2 days, and for 55, it will be 1. For 8 and 74, there is no answer. For 8, we don't see any warmer day. And for 74, it's our last element. There is no warmer day. So from the description, is it clear what is asked from us? Okay, folks, now I want you to think, because I have this code and I spotted a little bit, don't spot. But what do you think? Will we use increasing or decreasing order stack here?
Next increment.
Say again, Sandeep, because we didn't hear you.
Next increasing.
Yes.
We have to find out, yeah?
Yes, next increasing.
So it will be decreasing monostock.
Yes.
Monostock.
Yes. It will fall down to the task, which is we solve next Greta elements.
Right.
Box. Yes. So basically, it will be used the same patterns. How we're doing. So for answer, we will create an answer output with zeros. Then we will using this condition, where we will looking next warmer day. It will be our nums I, which is bigger. If we found, we will calculate manipulation. If we didn't found, then we will put it on the stack. For the smaller, there is only change that this condition is changed. That's it. So, yeah, this basically how we're going to solve it. It's we will initialize our result. In Java, it's by default will be 0, all the elements. We will searching for we will keep our candidates until we will found the warmer temperature. Once we will found the warmer temperature, we will popping out index. Just remember that we are preserving indexes in this case. And then we will calculate this one and we will push it. So basically, yeah, and that's how our decreasing stack will looks like in this case. So I'm done with monotonic stack, folks. If any questions. Because now we are going to move to completely different task. It could be still not click decreasing, increasing. You will try to solve task. I will share a few on the Slack with different approaches where increasing and decreasing. And also walk through I put them all together, next great elements and next small elements. Just put the difference, how we build the stack. In the stack, remember that we are preserving indexes. We don't need to preserve value because we know that value is in increasing order, and in the another task it's in the decreasing order. So it's not about indexes. It's not indexes in order. It is a value. That's from where we are taking confidence when we are building our output array. So that's it. Then let's move back. There is one I actually started just 5 minutes. There is another one approach how to solve next large number to write. When I put it, I saw that it is not really very intuitive, but you can just take a look in your time. I didn't remove it. Just for your learning, this slightly different approach for how next large numbers is found. It is not better or worse from what they are having the same time complexity, but I think the one which is we just discussed, it's more intuitive rather than this one. Just if you want, you can read it. I won't cover it because otherwise it will confuse you a little bit, the approach, but yeah. So let's moving on to evaluate expression. This is very popular one, and it's not easy one for me. It's personally. So I'm pretty sure probably it won't be very clear, like after we're done, because for me it took some time. And for this task particular, I was working with paper. I put everything on the paper, each step by step, because it's very brainy one. So that's what I will encourage you after we will discuss it. It probably won't be very clear after I will explain, but you need to take papers and just make the try run for yourself when you will be solving it. But it is very important to understand this task because it's very popular, as I saw it many times when this task was asked during the interview. So evaluation, yeah.
Excuse me, could you please share the link?
It is the same. I just just came to another one. Came back to the first whiteboard.
Thank you.
Yeah. Okay. So evaluation expression on the LeetCode, it's actually a basic calculator. Given a string representing a mathematical expression containing integers, parentness, addition, and subtraction operators, evaluate and return result of the expression. There is different type of basic calculator evaluation expression. In different one, it could be given the most simple one. You don't have parentness, and you just need to count the expression. Most of the case, it will be parentness. For the simple version of the calculator, it's allowed only two mathematical operators like subtraction and addition, which is we're going to cover today. I saw there could be multiplication and division. And also sometimes I saw that the digits can contain points, so it could be decimals as well. But in this particular one, we will cover. It's very rarely when there is tweaks, the one which is I explained it, but you should know. Usually it's asked in this form, where you have parentness, and you just should encounter two operation, addition and subtraction. From the perspective of the description, is it clear? What task? Okay, cool. So we just need to calculate what will happen in this expression. We will walk through. First, we will break down this task. We will try to solve without parentness. There is two main points which is you will need to understand. It will apply to any expression calculation in future. And then I will add parentness, and we will eventually solve with the parentness. So first, let's focus on this expression. There is already some complexity here due to presence, sum, and addition and subtraction sign. Usually in this task, how it is simplified. Instead of, so we will usually in this, it's always like this. I put here examples. Maybe it won't be clear. Usually we're doing this one. We're taking 2, which is actually sign here plus. Then we are treating all these operators as addition with small tweaks, because we are remembering the sign for each element. And what does it mean? So this is 28. It has sign plus 1. This is our 10. It has sign minus 1. But we are treating, we will treat all the operation instead of subtraction and sum as a addition, which is will eventually, once we will apply the sign, which will make this expression as an expression. as an original expression. Is it clear what I'm saying now? That in this task, we usually replace our subtraction with actually plus. But for all numbers which we will meet, we will track sign, either it's minus or either it's plus, which is eventually will give us the needed result. This is it's in the most task which used the same way. The next complexity will be because we have digits. Sometimes it could be 2 digits, it could be 3 digits. How we usually count this number, because input is a string, right? We're parsing this string on the chars. And now we need to understand whether it's 7, which is 1 digit, or it is 18. It's also, we're using this technique, which is applied to all the numbers when you're operating with any numbers. This technique is always applied. So we use this formula. Initially, we are creating variable which is current number. We initialize it to 0. And then when we are processing this string, it is our string 1, 2, 3, for example. We will parse on the chars. As we initialize our current number as 0, here it will be first 0. We multiply by 10. It will be our 0. We are doing plus 1 digit for the first char. We will receive 1. Next, our current number here now is 1 after this iteration. This is our first iteration. Now it is 1. We multiply by 10. It will be our 10. We plus the second char, which is 2, and we will receive 12. Next, now our current number is 12. Now what we are doing, we multiply it's on the 10. We plus 3, and we eventually will receive the right current number. Is it clear, this technique? Cool. There is some small snip of code, how it usually looks like. So imagine you have this char in your string. You are checking if it's digits, then you apply this formula. You update your current number. Then you come back to the next char. You are again checking if it's digit. Then you are updating your current number with new value. Doing this until you actually finish with your end number. So this is the two main points which we usually use technique during the solving any expressions LeetCode style task. So first one, you should remember, instead of using addition and subtraction as as the operators, just introduce sign. It will be another variable which will contain sign 1 and sign -1. And then you can treat all the operation on the expression as an addition. That's another point, how we actually calculate the number on the expression. So now that we covered this one, let's try to solve this task without parentness. How it will look like. Is it clear? Now we will go for dry run to solving this expression. Okay, cool, folks. So upon reaching the operator, we reach the end of the first number. So let's multiply the current number by its resulting product to do the update. -1, since the current operator is -1. Okay. So this is the snip of code, which we will use as a part of solving this evaluation expression. So the first one, we will calculate 28. We will start from the first char. We will first iteration will falling down to this. We will receive our 2. from where we receive our current number. It will be 28. So this is the first condition which we will met in our expression. Next, we will end it up that we will see -1 here as an operator. The rest we will keep this condition. If the current char is plus or -1, if it is, then we will track our result. Result is the final answer, which is we're going to return at the end of solving this task. This is our output. Okay, we reach these operators. We know there is no value. So our first result will be equal. So we're treating all the elements as a plus because it's positive. It could be negative here. Then we will start not from this condition, but we will start from this condition. So now that result, we will update our result. It will be 28. After we update our result, we know that operator currently is actually subtraction. We are updating sign here. But for result, just keep attention. Every time when we are updating our result is the one which is we are outputting. Means we're doing operation. Instead of doing here extraction or plus or minus, we are all the time doing plus. That's what I was talking about. And we keep updating sign here. In this case, we met the operator which is -1. We are updating it to -1. Or 1. In this case, it will be -1. And we will reset our current number. So that's what happened on the first iteration. We are updating the result. This is the second operation. We are updating our result by adding 28 to the result. We are updating our sign to -1, and current number will be resetting because before it was 28. Next, we will encounter next element, which is 10. Now we will hit this condition here. Our current number will become 10. Once we will encounter this one, we need to make the manipulation here. Sign from the previous iteration, from this iteration, we updated to -1, right? So first means on this point, once we will count 10, our sign -1, we will multiply -1 with 10, and it will be -10 here, which is plus on minus. Will subtract from our result 80. Once we did this manipulation, we need to update to the operators, which is next one. And next operators is actually addition. We update it to the 1, and we are resetting our current number, which was 10. Is it clear on this step? Okay, cool, folks. Next, we will have we will hit 7 here. And in order to, as we will out of the loop, once we will hit 7, because usually we're stopping on the operators to make this operation here, we actually will go out of the loop. And at the end, what we would need to do, we would need to add our last current number, which will be 7, and sign will be 1, because we are encounter there is positive sign, and we will just add at the end our 7. So which will give us 28 minus 10, it will be 18, and plus 7, it will give us 25. This is the whole task when we don't have parentness. So basically, we will have just 2 conditions to encounter digits. Also, if we will encounter operators, we will add a result because there is nothing. Plus and minus having the same order of operation. There is no order. We can freely increase our result. After each iteration, we need to update the sign, which will signify of the operator, which we're dealing with, and we need to reset the current number. in order to see what will be our next current number. I hope, yeah. Please ask questions.
Why when we come to 7, we will go out from the loop?
Yes.
Why?
Because string will be finished, right? Once you will encounter this our string, this
Okay.
will be our last char.
Yes.
You will falling down to this condition. It will be our last char. You will encounter current number, but you need to do this last step. And you didn't do this because we're doing this step only we encounter next operator. So imagine how it is work.
Yes, I actually I understand why we must do the last line of the code, but my question was when we understand that we must we are in the end of the loop, you know.
Say it.
For example, when we come to 7, we must find out we are end of the loop, right?
Yes.
And we must go out. Which one of the line of the code we do that?
This is the loop in the string. This is loop. Inside of loop, we have two conditions. We are differentiated between digits and we differentiated between operators. We increasing results on results by stepping. Once we found operators, we increasing results. See, and in this string, once you will encounter digits, which is will be 7, it's our last. We haven't yet add this result, this value to our result because we went out of the loop. But in code, if I correctly understood your question, where I think I put it code here. No, I probably need to update it. 1 second. I will just add the code at the beginning. I actually added it. It seems was not syncing. Just 1 second. I will add the whole code because it should be here, and it's not here. Should be here. Interesting. Let's stop here. Experiment. Daily temperature. Okay. So this is the whole code, but it is already including also parentness. So just keep parentness part here, folks. We are going from the for loop. These the conditions. These two conditions which is we currently covering. Once we went out of the loop here, this is on the return result. We need to add our last value of the digit. Is it clear? If it's not clear, just ask.
Yes, it makes sense now. Thank you. I understand it. Thank you.
Yeah, so it's the last digit which we have in the expression because the expression should be valid all the time. So whatever it is can't be that expression will looks like this. It is invalid expression because this is as a constraint and as a promise of the task. Will be always last digits, and as our algorithm is built in that we are updating our result only we encounter operators, means this part will be always missing, this one. That's why at the end we need to add our last expression or digits whatsoever. Yeah. So any other questions? Before I will moving to the adding expressions parentness here. Okay, cool. Evaluating expressions containing parentness. Now that we know how to evaluate simple expression, it's time to bring parentness into discussion. So one challenges here associated with nested expression is making sure that we process nested expression in the right order, right? So if we will take as an example this expression with the parentness, first we should solve this one, then we should solve this one, and only after this we need to solve the whole expression, I mean to engage our 18. So this is adding complexity. Similar to what we did with valid parent expression and opening parentness indicate the start of new nested expression, whereas the closing parentness indicate the end of one. Understanding this, we can use stack to solve this expression. It's probably not clear yet why we need to use stack here. And forgot about monotonic and decreasing stack. It's not absolutely, it doesn't falling down to this one. It's falling down on the valid parentness expression at the beginning when we encounter that we actually need to consider the very recent use of the parentness against the one which is we just met. That's what I'm trying to explain here. So our parentness actually in this case will be indicate that operation is actually started, and the end will indicate that operation is actually ended. That's why we would need to use stack here. Let's try to make dry run, and probably it will make sense better. If it's not, I will take questions and we will try a different approach to explain this. So at the first opening parentness, we know a nested expression has started. Before we will evaluate this nested expression, we will need to save the running result of the current expression, as we will, as well as the sign of the upcoming nested expression. This way, once we're done evaluating the nested expression, we can resume where we were in the current expression. So here's the step for when we encounter an opening parentness. So we will split our operations on opening parentness and on closing parentness. Meaning, if we before was dealing with two just conditions, here we will dealing with two more conditions. We will add opening parentness and we will add closing parentness, and we will do different things on each of these conditions. Okay, let's try to make dry run. So first one, rest. This part should be clear for you folks, right? How we receive here result 18 and how we receive here sign -1. Now that we encounter, yeah, that's why I skip it. Thank you, folks. So now that we encounter open braces, it's our index pointed to open braces, we need to preserve what we did so far because it's not yet engaged on our stack. We're pushing our stack result and we're pushing our into stack sign. Then we will reset our res and sign here. set this variable because we're about to be calculated a new expression. So we remember this one. Now we are resetting our result and sign because we have open braces and we need to solve expression this separately from this one. Next parenthesis we encounter is an opening parenthesis again. This indicates the start of a new nested expression. As we didn't encounter any closing expression, this is not giving us that we need to actually finish this expression. So in this case, we will keep saving our previous calculation on the stack, where we are again. This part is remain the same from the expression without parentheses. This one will remain the same. Everything what we are doing here we just on the opening braces, we will preserve our result because the expression is not yet finished. There is no indication on the closing parenthesis. So this is the condition how it is looks. We're putting result, we're putting sign, and we're putting and we reset result and sign. Our stack will looks like this: 18, -1, 7, and 1. This is all about sign. It will make clear. I will keep going over the iteration, and if there is won't be clear, I will take answer. Yes, Sandeep.
Lilia, just one doubt. Are we not storing the opening parenthesis in the stack, like 18 -1, and then the opening bracket and 7 and 1, so that once we are going in a reverse way, from inner loop to outside, we will see what all elements are there. So because in current presentation, I don't see this opening braces in the stacks. Yeah.
See, this is the condition which we are hitting. This is the open braces.
Right.
Yet on the expression, we keeping pushing this result and sign because there is no indication that this operation is actually finished. This expression is actually finished. The main point here to understand that once we are including in the expression parentness, means we should solve all this nested expression separately, and then we should go down to the result, as I explained it here. So what we are doing here, it remains the same without parentness. Once we encounter parentness, we are preserving this result because we can't make the final result yet, because we need to solve in the right order all the expressions. We keep going until all these open braces will indicate about beginning of the operations. But the closing operation will indicate about that expression is actually finished, and we can calculate it. But for this reason, we will use stack, because see, this is the something which is indicate the dynamic of the stack. First, we keep going until we will have indication that expression is actually finished. And in order to keep going, because all this expression, this is the first expression which we need to solve, then we should add to this value, and then we should add to this value, which will indicate the dynamic of the stack. Does it make sense? If it's not, we will go back to the dry run because I didn't finish on the, and probably it will make sense. If it's not, we will come back.
Just one thing. This will work if we will have another loop also, like like 7 plus, then there is another bracket, and then plus some number, and then plus 2 - 4 within another bracket.
A loop? No, we don't need loop. We just
loop in the sense like the bracket. Like how we have 2 + 4 within one bracket. Yeah. So this will work if we have another bracket, another set of brackets.
Ask again your question.
I mean, this will work if we will have another set of brackets also,
Ah,
because we are not preserving the brackets in the stacks.
another, you mean different type of braces?
No, the same bracket, but
Uh-huh.
for example, 18 minus 7
Uh-huh.
and then plus 1 minus 2 within another bracket.
Can you type, you
Sure.
refer to different expression on the
Okay.
chat.
Yeah.
I will.
Yeah, I think Sandeep was saying like there is a bracket before 18. So it's like bracket and then some calculation on two numbers, then plus, and then there is another bracket. So it's like if you type it here, maybe I can mention it's like bracket 18. So if you start again, yeah. So opening bracket
Open it. Okay.
18 plus 7,
Mm-hmm.
and then maybe closing bracket,
Uh-huh. And
then
here,
plus plus or minus whatever, and then bracket start.
+9.
Before 9 there is a bracket.
Okay.
Yeah,
And here
9 plus 2.
+2. Yeah, it will work.
And then close bracket, something like that.
Yeah. You mean when this order is actually the equal one? Yes. This condition will work. The algorithm which is we're trying to define now, it will work for this kind of things. Yeah, it's not obligatory that you have this input. I took this as an example, but it will be the same. We can do. We're running out of time. What I will encourage once I will finish with this one, you will check on your own. I believe I included test on the, but this algorithm should work for any order of braces. So, yeah, whatever nested, not nested, or they equal, it should work on the time. Just because we don't have time, I encourage you to take this example and map on my code and see how it will work in the dry run situation. Okay, next parenthesis we encounter is an opening. Again, it will be opening. This is how our stack will look like. I'm moving. The next parenthesis we encounter is a closing parenthesis. This means the current nested expression just ended, and we need to merge its result with the outer expression. Here's how we do this. Here we will updating our result. We will stack pop, which will be, so in this case, it will be, once we will encounter, first will be 2 minus 4. So current number and sign stack pop middle if add result before current, so result sign will be minus and encounter. Okay, so we will calculate the expression. We will start, so basically once we will encounter this one, we will preserve this one on the stack, knowledge of 7 and sign +1. Then we will fall down to the condition just to solve this 2 and 4 first. We are not preserving, so this is the important things to understand. When we encounter open braces, we are preserving what we calculate so far. And in first iteration, it was 18 and minus sign. Then in the second encounter of the open braces, it was 7 and it was plus. And once we will do 2, it will be our simple expression first. So we will encounter 2 minus 4. We will solve this expression. And now here, no opening braces at all. So we will calculate this expression, which will give us -2. Once we will encounter closing braces, we will go this way. So we are popping up, apply the sign of the current nested expression to its result, add result to the outer expression. In this case, first, we will do our expression, sign before parentness, result, and we will so in this case, it will be, once we will encounter, just 1 second, I will do for myself try run. We will solve 7, we will solve on here. Next, we will go to 2. 2 will be here, it will be our current number. Then we will encounter minus, it will go here. Here we will add to our result 2. You're following, folks, for me. I'm doing the dry run, so this step after we encounter, so we preserve this one. Currently, I'm on the 2. We met 2, it's our current number. Here will be, then we encounter our minus. We are updating our first result here because all the time we are resetting result. Result should be 2 in this case. It will be result 2. We are saying there is -1, and it will be our 4. 2, result 2, next -1. We will go here. It will be our 4. Next, we will have closing parentness. Now our current number is actually 4 here. First, we will calculate our current number, and sign will be -1 here, multiplied by 4. And in this case, it will be our result, which is equal to. Is it clear what happened once we will encounter the closing one? Okay, so means our new result in this case will be -2, right? Because we have sign -1, and what is 2 minus 1? So here, next, what we're doing, on the pop, we have our res stack, it's our sign. In this, our sign it is a positive one. So our result will remain -2. And here we're taking 7 from the pop. First it will be sign, then we're taking value. And it will be our 5 here. So basically we will solve on the encountering the closing braces, we will solve our expressions here. It will be 5. Is it clear? Okay, cool. Next, we will encounter again our ended braces here. We will encounter, and current number is 0 here. It will rename 0. So now that we encountered this one, what on the stack is left? Result will be, our result in this case will be 5, right? Then we're having stack. We are saying our result is -5 in this case because we preserve the sign, which is -1. And next, what we are doing, we are taking, we are saying that -5 plus 18 will give us answer 13. And we went out of the loop here. Our current number is actually 0 now. We just will give 0, and as a result, we will return our 13. Is it clear? If it's not clear, as I told you before, it's probably not still clear. Just take a different task with the one which is Sandeep asked, when the parentness is actually equal, when the parentness nested, and try to solve the dry run, which is I did just now. So this is the code in Java. how it is looks like. Yeah, and so and I think I finish for today. Any questions, folks? And you should have a link for our next week challenges. So daily temperature, valid parentness, and basic calculator, the one which we just discussed. Feel free ask any questions. It's very silent, folks.
That was awesome. Thank you so much.
Oh, you're welcome. I hope it is makes sense.
It
It's a
was.
silence because of digesting things.
Yeah.
So yeah, it will take some time.
Yeah, yeah,
But
but lecture is nice. Yeah, thank you.
yeah.
It is either everything is clear, either nothing is clear.
If it's not clear, just feel free to put on the Slack, and if it's still not clear, we can cover next week again the basic calculator, because it's a very difficult one. It is one of the difficult for me as well.
I have just one question. So here we are dealing with the only one kind of parenthesis. Is there any chance that we encountered a question with like 3 different parentheses and then we just use dictionary
No.
with it? No? Okay.
No. It's usually should be one, but there is sometimes complexity added by having the division and multiplication as well. So there is another way you should take into account of preserving
Okay.
order. Yeah, the
Okay.
tense.
Just one more thing. So, even in the previous question where you actually shorten the question to help us understand the concept, where we're not dealing with the parentheses, only the plus and minus. So there, like you explained that we have to maintain a sign for the minus and plus, and we always do the addition.
Yes.
But yeah, so one thing which I'm not able to understand that what is the benefit of just doing addition and maintaining the sign. Can we do it this way also by just having one more if else condition where we checked if the sign is plus, then we do result plus, and if the sign is minus, like the character that we are reading from the string, if that particular character is minus, then we do result minus the value. Or am I missing something here?
You can't do this by maintaining let me think. So basically, you have this number, right? You encounter it here. So just we'll come back. So you encounter it here. Once you encounter, you come back to the digits, right? You come back to the digit, and you should keep tracking your previous sign for this. It won't be like in this case, what we're doing, we're updating sign for the future digits. What you can do, so for example, if you do sign here, maybe it will work. Here you took previous sign, and you remember whether it's minus or it's plus 1. Next, when you take these digits, you encounter another one plus. So, for example, you encounter 1 plus. No, it won't work. See? Where you were,
I understand we have to maintain it, and at that time we cannot use this variable like result, like then it will be another if else condition. We have to check what's again in the previous sign, and it's not that readable. Yeah, I understand. Yeah, I got it.
You're right. Yeah.
Just one more thing. So, like, you shared this snapshot of the notes on the Slack. That is very comfortable to revise and everything. But just to add, is there any possibility to share the link of this particular file, like, so that we can open it like single notes and access the previous one at the same time?
What do you mean? I
I'm
usually
saying
sharing a whiteboard. I believe the last time I shared link on the whiteboard. You want to
actually,
the whiteboard, right?
yeah, I mean, whenever I access the link, I think you shared when we start you start the class as well. But whenever I access the link, I get only the latest notes, not the previous. So here on your screen, you can see there's a week 3, and then there's a binary search for the week 2.
This
So
one. Yeah.
yeah.
You mean if there is could be some folder on which you can access all the notes? I will take a look if it's possible.
Yeah. I think there is an option to save this particular file and then share. Like, I'm not very sure. I'm not also very familiar with this particular whiteboard. But if there is any possibility, because I think notes are really, really good. You already, put a lot of effort into it. If you can access it at one place, it will be great for,
Yeah.
maybe adding something more to the same one rather than creating notes at a very separate places. So.
Yeah, sure. I will think how to organize this better. Yeah,
Yeah, please.
100%.
Yeah. Yeah, but
Lilia,
thank you so much. Yeah.
You're welcome.
yeah, just to add on regarding the challenges also, uh,
Uh-huh.
because when you share a link, it will be only like a current challenge. How to access previous challenges, like if not completed, like because if I'll go back, I'm not able to access.
Challenges on the HackerRank, you mean?
Yeah, these challenges which are specific to our courses, like LeetCode Summer Bootcamp from 0 to Frank
Can
0.
you try access this one? So for example, this one will be 5 weeks. Can you
Yeah,
click?
but if I want to access all the, from 0 to 6 week,
Okay.
just
Yeah. Uh-huh.
how I can do it?
Let me think, Fox. I actually was about to update GitHub, and probably it's the best place where I will include all the resources, like all the contest links and all the links on the whiteboard sessions. And
Okay.
it will be in one place where you can iterate over all the previous weeks ever what we have. But
Right.
yeah, you usually I just change. Usually as we are on the 6th week, we started from 0. You just need to change at the end like 4 or 5, and that's it, and you will open. So just the last digits. It's
Yeah, I tried actually that, but fine. Okay.
work.
Yeah, it worked.
Perfect.
Yeah, you also can monitor our updates in Slack as we publish it in Slack as well.
Yeah. On the Slack, yeah, we're usually updating for the week, and sometimes we're updating for the whole week. So yeah, we will think how to make it better in one place to organize, because we are growing with our weeks, numbers of weeks.
Good.
Yeah.
Thank you so much.
Thank you, folks. So
Wish you a lovely weekend.
thank you so much, and you too. Next week we will start at 11, folks. Just remember. Thank you. Have a lovely weekend, folks.
Yeah, thank you so much again.
Thank you.
Окей. Все ушли.
Короче, мы не начали рекординг, но сессия должна быть записана автоматически.
Да, я вижу. Тут кнопка Stop Recording. Но она уже включается, когда начинается meetup. Так, останавливаю, да?
Да.
Так,